This is a quick lesson on ionic bonding. By the end of this lesson, you will be able to describe and model what happens when ions bond. So we've talked about how to model atomic structure, so where the protons and the electrons go. We've talked about ionization, so how to figure out what charge ion a specific atom makes. In this lesson, we're going to talk about what happens with those ions. So specifically about the stability of atoms. Atoms form ions in order to become more stable. They want to have 8 valence electrons. It makes them more stable and less reactive when atoms form ions. However, once an atom ionizes, it then has an electric charge, either a positive charge if it has more protons than electrons, or a negative charge if it has more electrons than protons. When two ions with opposite charges come into contact with each other, they're attracted to each other. They'll form an ionic compound held together with an ionic bond. This attraction is an electrostatic attraction. It pulls the ions together and it forms a compound. This compound is more stable than either of the ions separately. And stability means that an atom is not very reactive anymore when it has formed a compound. So let's look at an example. We're going to look at the reaction between sodium and chlorine. So first, let's find sodium on the periodic table. It's over here in group 1. Sodium, because it's in group 1, will make a +1 ion. So we have Na plus, and chlorine is in group 17, way over here. Everybody in group 17 makes a -1 ion. But what's really going on here when sodium and chlorine get together? Let's describe this a slightly different way. You know that sodium is in group 1, so it has 1 valence electron. And chlorine, because it's in group 17, has 7 valence electrons. So we're going to draw dots around the symbols to represent just the valence electrons. Because remember, only valence electrons are involved in bonding, none of the ones under the valence shell. So this is what happens. Sodium, gives away a valence electron to make that +1 charge. Chlorine takes that valence electron to make its -1 charge. So sodium is giving its valence electron to chlorine. Now sodium has 8 because the energy level below the valence shell now becomes the valence shell. Chlorine gets 1 more and it now has 8 valence electrons. So when this happens, they bond with an ionic bond and make NaCl, or sodium chloride. Let's look at another example, magnesium and fluorine. So we have magnesium. A check of the periodic table shows that it has 2 valence electrons because it's in group 2. And fluorine is in group 17, so it has 7 valence electrons. So let's see what happens here. Magnesium needs to give away 2 to make its 2+ ion. Fluorine wants to gain 1 to make F-, the fluoride ion. So magnesium can really easily give fluorine 1 of its valence electrons. Well, here's a problem. Magnesium has 1 more to go in order to have a full valence shell. It wants to get rid of both of these, so the next energy level down will become its valence shell. So what if it finds another fluorine? If there's 1 around, surely there will be more than 1. So here's another fluorine with 7 valence electrons. Magnesium can give its other valence electron to the other fluoride ion to make an ionic bond. So here, instead of just MgF getting together, we're going to have 1 magnesium and 2 fluorines. So here's your turn. Write the symbol for each ion and draw a dot diagram. So that's when you write the number of valence electrons as dots around each symbol. And then use an arrow to show the movement of electrons. Hit pause and hit play when you're done with all 3. Let's go over all 3 together. You've probably figured out that potassium is in group 1, so it has 1 valence electron. And fluorine we looked at in our example, you know that it has 7. So we're going to draw 7 dots around fluorine. And this is a match made in heaven. Potassium has 1. It's just going to give it to fluorine. Now that they have opposite charges, they're going to be attracted to each other. Sodium and oxygen is a little bit trickier. You know that sodium has 1 valence electron, and oxygen has 1, 2, 3, 4, 5, 6. So it will be easy for sodium to give 1 to oxygen, but then oxygen needs 1 more. So it's going to find another sodium that has 1 valence electron, as they all do. And this sodium is going to also give a valence electron to oxygen. So here you have Na2O as our ionic compound. And finally, beryllium. You find on your periodic table that it has 2 valence electrons. And we just did oxygen, so you know that it has 6. Beryllium really wants to give away these 2 so that it has a full valence shell underneath, and oxygen really wants to. So this is easy. Beryllium gives both of its valence electrons to oxygen, and you end up with BeO, 1 beryllium for every 1 oxygen. One more question for you. Why do atoms form compounds? Write down your answer after you hit pause, and then we'll come back in just a minute. So atoms form compounds in order to increase their stability and decrease their reactivity. So if you have an atom that doesn't have 8 valence electrons, it's going to give away or take valence electrons and then form compounds to become more stable and less reactive. So by now you are able to describe ionic bonding and also model it using dot diagrams and arrows.